Hello. Hello. Yeah, I think I'm audible. Good evening, everyone. Welcome to this class. Today we are going to take this topic called as definite integration. You can follow me on Unacademy at RM sir. This is my code, and this is my profile link also. You can use my code RM sir to get any subscription on the Plus platform. Okay. Now today we are going to study definite integration, and in that also the properties of definite integration. Like we have a lot of important properties, and it will help us to solve many questions, that too without integrating the questions. Like in indefinite we used to integrate the question. In definite integration we have upper limit lower limit concept, and that too we are going to use the properties which will help us to solve majority of questions. Before that, I'll just let you know that unsat test, it was on 8th of October, and the next one is on 15th of October. So you can register for this test, and many students have already done this test and they are trying to do it again. This is for class 12 pass students, class 9 to 12th also, for IIT JEE or NEET students. Okay, so you can register it today, and you can use this code RMSIR to register it. Okay, and this is the upcoming batch. It's already started from the 6th of October. Okay, these are the educators taking physics, chemistry, and maths and biology. Their mode of delivery will be in English. So do join this batch, and to register for this batch again you have to take a Plus subscription using this code RMSIR. Okay, so Mohana ma'am is taking physics, Manisha will be taking chemistry, and Lakshya sir will be taking biology, and I'll be taking maths for this batch. Let's start with the topic, and before solving some questions I'll just list out the properties, and we'll try to solve each question, one question on each property, one or more than one. Let's start the properties of definite integration. Properties of definite integration. Here the most important and the easy property is, if you write from a to a of a function, then the value is 0. When a definite integration is given from a to a, then the value becomes 0. Similarly, if a function is from a to b, f of x dx, and you wanted to change the limits, like the lower limit will become the upper limit and upper limit will become the lower limit, then you can write minus sign here, and that is f of x dx. Okay, and the third property, these are three easy properties: a to b, f of x dx, a to b. Instead of x you can write t, instead of x you can write t, and this will become f of t dt. So these are the three very basic properties and also very important, but majority of questions come on the properties which we are going to take on the next slide. But majority of questions will come on the properties which will be on the next slide. Okay, so I'll just go through these properties again. A to a is f of x dx, a to b if the f of x dx is there, then it is minus b2 f of x dx. And if a to b f of x dx is there, instead of x you can write t. Okay, fine. Let's just add few more properties, and from here we'll take questions on each property. See, a to b f of x dx, you can write or split any particular integration at point C f of x dx plus c to b f of x dx. This property is mostly used when the function changes its behavior from the interval a to b. For example, I'll take 2 to 3 examples based on this property. Let's say you have f of x is given. Let's say f of x is given. Okay, let me just erase this part. Two x minus 3 when x is less than 3, and 5x plus 1 when x is more than 3. And the question is asked, just a minute, and the question is asked, find the integration from 1 to 5 f of x dx. See, f of x is given what? 2x minus 3 when x is less than 3, 5x plus 1 when x is more than 3, and it is asked that, okay, we'll write equal to 3 here. It is asked that find the integration from 1 to 5 f of x dx. So as we can see, hello Abhishek, hi Ishan. As we can see that the function is changing its behavior at point 3. Am I right? As we can see that function is changing its behavior at point 3. So 3 is in the interval 1 to 5. So we'll start breaking this function at 3. So 1 to 3 f of x dx plus 3 to 5 f of x dx. Okay. So why we have broke this function at 3? Because it has a different behavior before 3 and after 3. The nature of function changes at 3. Now from 1 to 3, if you see that the x is from 1 to 3, right? So in this we can write f of x as 2x minus 3 dx plus in 3 to 5, if you check here, you can write the function as 5x plus 1 dx. Okay, now from here it's very easy to integrate. Like the integration of 2x is x square, integration of 3 is 3x. So here you can put the values 1 to 3. Similarly, integration of 5x is 5x square by 2, integration of 1 is x. In this you have to put value 3 to 5. So here you have to put the upper value, which is 9 minus 9 minus lower limit, which is 1 minus 3, plus put the upper value here. So it will be 125 by 2 plus 5 minus put the lower limit 3. If you put here, then it is 5 into 9, 45 by 2 plus 3. So once you solve this value, you will get the final answer. Okay, I am not solving this part to simplify it. The main purpose was for this question was to learn the property where we are going to use it, where we have to break the function. I'll take one more question based on it. Okay, based on the same property. Today's target is to take 1 or 2 questions on each property. Okay, so this was the 4th property, and it's a very important property. Let's go ahead with the one more example based on 4th. Integration of 1 to 5 mod of x minus 2 dx. So as we can see, it is asked that integration of 1 to 5, and as an integrand there is mod of x minus 2, and the function which is to be integrated is mod of x minus 2. Here we can see that x minus 2, if you equate to 0, if you equate the value inside mod at equal to 0, you will get x equal to 2. It means mod changes its behavior where the value inside mod becomes 0. Mod changes its behavior when the value inside mod becomes 0. For example, if you know this graph of value mod x minus 2, it is something like this. It will become v shape at 2 comma 0. Okay, so first branch is different and the second branch is different. So you have to break the function at x equal to 2. X equal to 2 dx plus 2 to 5 dx. Now what should we write over here? So if you check that between 1 to 2, mod x minus 2 will act as negative of x minus 2. Try to understand that mod has two types of behavior. Try to understand this part. Mod has two types of behavior. The one which is this is minus of x minus 2, and the one which is this is x minus 2 plus. So before 2 it's minus of x minus 2, and after 2 it is plus of x minus 2. So I'll write now plus of x minus 2 here. Now let's integrate this term by term. So integration of minus x is minus x square by 2. Integration of plus 2 is 2x. In this you have to put value 1 to 2. Similarly here, x square by 2 minus 2x. In this you have to put the value 2 to 5. Okay, now let's put the upper value. Let's put the upper limit. If we put the upper limit, what we are getting? See, minus 4 by 2 minus 2, and here plus 4. We put 2 here minus. Now put the lower limit. Now put the lower limit minus 1 by 2 plus 2. Similarly here put the upper limit. You will get 25 by 2 minus 10 minus, put the lower limit, you will get 4 by 2 minus. Now let's simplify this. You will get 2 plus 1 by 2 minus 2. Here we will get 25 by 2 minus 10 minus 2 minus 4. 2 gets cancelled. 25 by 2 and half is become 13, and this will become minus 10 plus 2, which is now 5. Okay, hopefully everyone is getting this part. Okay, let's take the next property. Let's discuss a few questions on it. Now the next property is the fifth one, which is a to b f of x dx. You can write this as a to b. Instead of x you can replace a plus b minus x dx. Instead of x you can replace a plus b minus x dx. This is also called as king rule. Okay, now let's practice some questions based on it. This is the first question. Let's say 2 to 3 root x upon root x plus root of 5 minus x dx. Okay, this is the first question which we are solving on this. Let's assume this equation as I. Now let's apply the property. What does property say is that instead of x you can replace the sum of limits minus x. Sum of limit minus x. So instead of x you have to replace that. Here also instead of x 5 minus x dx. Now here 2 to 3, it becomes root of 5 minus x upon root of 5 minus x plus root x. Now look at these two equations, okay? The one which is before property and the one which is after property applied. The first one and second one, both are equal to I. Am I right? Both are equal to I. So now if you add these two, equations, see what we are getting. I am writing it in the next slide. If you add these two equations, see what we are getting. 2y. As the denominator is same and the limits are also same. 2 to 3. So denominator is also same. So we'll write root of x plus root of 5 minus x. And in numerator we'll get root x plus root of 5 minus x dx. So from here we can say that 2y is equal to 2 to 3 1 dx. Condition of 1 is what? X. 2 to 3 2y. Now upper limit minus lower limit, that becomes 1. So I is equal to 1 by 2. This is what the integration is. Okay. If you actually observe, we have not even solved the integration, we have applied the property and we have got the answer. Okay. If you actually observe, by applying the property we got the answer of the value of I as 1 by 2. Okay. Now there is an important note over here. Just try to write this on your notebook. A to B f of x upon f of x this. Here I is this. So try to observe f of x upon, there should be the same function f of x plus f of a plus b minus x. The value of I in this case will be b minus a by 2. Try to remember this shortcut, it will help you to solve the majority of questions. Okay. We'll solve some questions based on it. The function should be there and in denominator the complementary pair like a plus b minus x number should be there. Let's take an example. Integration 0 to pi by 2 sine cube x upon sine cube x plus cos cube x dx. As you can observe, we have a function in numerator, the same function in denominator also, f of x, sine cube x, and then a complementary pair cos cube x. In this case, what is a complementary pair? Let me explain that first. यहाँ पे we have a x, right? This time we have a x here, and the same function we have sine cube x here, and here it is sine cube x, and the same function we have sine cube x here. Now instead of x, if you write a plus b minus x, instead of x, if you write a plus b minus x, it becomes pi by 2 plus 0 minus x, and then we got converted into cos cube x. If you put x के जगह पे pi by 2 plus 0 minus x, we'll get cos cube x. So this concept is applicable over here, and it comes to be pi by 2 0 minus 2, which is pi by 4. B minus a by 2, which is pi by 4. I hope, is that okay? Okay. We'll take one more important property now. Which is property number 6. Zero से 2a f of x dx is 0 to a f of x plus f of 2a minus x dx. This is also called as Queen's rule. Like in this, if you have a limit from 0 to 2a, this will help us to change the limit to 0 to a. Like as we can see, we have a limit from 0 to 2a. If you are willing to change the limit or make the half of the limit, then it will help us to get the limit from 0 to 2a to 0 to a. Make sure that this part, the lower limit should be 0. While applying this property, make sure that the lower limit should be 0. Okay. Let me take one example based on it. If you have 0 to pi, if you have 0 to pi, just a minute. If you have 0 to pi sine square x dx, okay, this question, the first thing is you can directly integrate. The second thing is, if you want to change it from 0 to pi by 2, you can change it to 0 to pi by 2 sine square x. Instead of x, you have to write pi minus x. Okay, this is, see, no need to apply a property over here. It's not compulsory to apply in this particular case, in this particular example. I'm just trying to explain to you how to apply the property. Where to apply the property, that will take few more questions after that. Okay, so here right now it's not that important. If you try to solve with this property, without this also you can do it, but let's finish it with this also. So sine square x, and this will also become sine square x. 2 times 0 to pi by 2 sine square x dx. Now you just have to solve the integration of sine square x for the limit 0 to pi by 2. So if you know the Wallis theorem or the reduction formula, in that case the direct formula or the value is there for this, which is 1 by 2 into pi by 2. So the final answer here is pi by 2. Okay, the 2 gets cancelled and the final value is pi by 2. For sine square x 0 to pi by 2, using Wallis theorem or reduction formula, we can write 1 by 2 into pi by 2. I'll try to take the reduction formula in the next slide that we have used here. Okay. Reduction formula. Zero to pi by 2 sine power nx dx. So here n should be more than equal to 2 and natural number, and n belongs to natural number. That is important. The formula is in this way, like you have to write n minus 1 upon n into n minus 3 upon n minus 2. Then you have to keep on multiplying. In the end, either 2 by 3 will come or either 1 will come, depending upon the n is even or odd. Okay, or 1 by 2 will come, depending upon it is even or odd. Okay, let me just take an example. In the end, you will be getting 1 by 2 or 1. Okay, I'll erase this part and we'll take an example. It will be more clear with you. Zero to pi by 2 sine power 3x dx. So you start with one number less, like we have a 3 here. You start with 2 and write the bigger number 3 here. Like you start with 2 and then write 3, and after this keep on reducing 2 from each number. After this keep on reducing 2 from each number. So in this case, if you reduce 2, it will get 0. So no need to reduce more than this. No need to reduce more than this, because it will get into 0. Okay, so here it is 1. That's it. Let me take one more example. 0 to pi by 2 sine power 7x dx. So you start with one number less by 7, like you start with 6 by 7. 7 से एक नंबर कम होना चाहिए, like 6 upon 7. Now you reduce 2 from each. 6 minus 2 is how much? 4. 7 minus 2 is 5. Again reduce 2 and then 3. Again, now if you are going to reduce 2, it will become 0. Okay, so no need to reduce from here. That's it, 1. In the end, 1. After 2 by 3, write 1. When the power is even, for example 8, so in that case you need to make sure that start with 7 by 8, one number less by 8, then reduce 2, you will get 5 by 6. Again reduce 2, you will get 3 by 4. Reduce 2 and numerator and denominator both. Okay, again reduce 2 in numerator, you will get 1, and here 2. Once you will get 1 by 2, you have to stop here and then multiply with pi by 2. So in the end you have to multiply with a lambda. Lambda is 1 if it is odd, if n is odd, and lambda is pi by 2 if n is even. You have to multiply with 1 or pi by 2 in the end, depending upon the powers are even or odd. If power is even, multiply with pi by 2. Power is odd, multiply with 1. The same thing is applicable for cos also. Let me take one more example. Cos power 5x dx, and here also cos power 6x dx. So for 5 you start with 4 by 5. One number less is 4, and then denominator में 5. Then 4 minus 2 is 2. 5 minus 2 is 3. You stop and write 1. For odd power, write 1. You start with 5 here, then by 6, reduce 2. After reducing 2, you will get 3. Here you will get 4. Again reduce 2, you will get 1 and 2, and stop here by multiplying pi by 2. So if you are trying to simplify this, like 3, 2. Okay, so 5 pi in the numerator, and 4 into 2, 8. 8 into 4, 32. This is your answer finally. 5 pi by 32. Hopefully you got this everything. So don't miss the plus batch. Okay, if you are willing to enroll for this, use this code RMSIR, and also go ahead with the test. It's a very interesting test. We'll meet in the next lecture. Okay, bye everyone.